Hello and welcome to this third session on the binomial theorem. And in the last session we just carried out some straightforward expansions using the binomial. But in this session and in the next two sessions we're going to look at different kinds of questions that are a little bit more advanced and require a little bit more thinking. And I've tried to group these together so they've all got a similar sort of flavour, just so you get an idea of the kind of things you're more likely to be asked than just a straightforward binomial expansion. It's very rare in an exam that you'll just be asked to expand using the binomial. There'll normally be a more targeted question. So let's look at some of the types of questions we might get asked. So nice and straightforward here, instead of being asked to expand a whole thing, we're being asked to find a particular coefficient in the expansion. We're finding the coefficient of x cubed y cubed in the expansion of x plus 3y to the sixth. Now you could, if you had lots of time on your hand, just expand out the whole thing just like you did before and then pick out the coefficient of x cubed y cubed from your full expansion. But we can be much smarter than that, and we can use the formula that we've got down here at the bottom of the page and go straight to the term that we want, because we know each term is made up of using NCR a to the n minus r, b to the r. So in this case, we're going to want the case where our n minus r and our r are both 3. So we're going to be looking at 6, because that's our value of n, c 3, x to the power of 3, and then 3y also to the power of 3. That would give us a coefficient at the end of x cubed and y cubed. And then this is just a case of working that out on our calculator. So 663 is 20, 20x cubed, 3 cubed is 27, 27y cubed. Multiply all that together and we get 540 x cubed y cubed. Now don't just leave your answer like that. Remember, the question asks for the coefficient of x cubed y cubed. So make sure you tell the examiner you read the question. So say coefficient is 540. And there's your answer. So you're more likely to get a question like that where you have to go straight to a particular term and find it. You might be asked not for a particular coefficient, but for a particular term. And I wanted to show you this question because people often make a silly mistake here. And they think, oh, the fourth term is where b, the second bit, is to the power of 4. But that's not the case, because if you think about it, the first term here is going to give us 2a raised to the power of 10. That's the first term. Second term 9. Third term 8. Fourth term 7. I'm going to end up with 2a to the power of 7, and my second bit, 3b squared, is going to be raised to the power of 3. This is because in an expansion to the power of 10 there are 11 terms, and it starts with b to the power of 0, not b to the power of 1. So remember that, don't fall into that trap. It's a really easy one to make. But now I know that it's n minus r is 7 and r is 3, then I know my first bit of the formula here, NCR, is just going to be 10C3. Now that's not too difficult now, just about doing the maths. 10C3, 120, 2 to the power of 7 is 128, 3 to the power of 3 is 27. Just getting rid of all of the coefficients first, and then I've got a to the power of 7, b to the power of 6, because b squared raised to the power of 3 is to the power of 6. Do the multiplication on the calculator and I get a nice large result of 414,720, a to the power of 7, b to the power of 6. Now in this case they wanted the term, not just the coefficient, so I'm going to leave my answer as, sorry, there should be 0 on there, 414,720, a to the 7, b to the 6. There's my answer. Don't forget, the fourth term isn't the one with b raised to the power of 4. It's the one with b raised to the power of 3. We might get a kind of solving question where we have to use what we know about the binomial to find missing values. And in this case, we've been asked to find the values of a, b and c in the expansion of 2 plus ax to the 7 equals b plus 224x plus cx squared plus 70x cubed. So we need to look at that and think, what can we find out easily? Well, the thing that springs out first of all is b. We can find that because we know the first term in this expansion will be our value for a, which here is 2, the first bit of the formula, raised to the power of 7. So we know that b must be equal to 2 to the power of 7. And if we work that out on the calculator, that's 128. So that wasn't too bad. So the first term there is 128. What can I find out now? Well, I know that the second term, which we've been given the solution 224x, I would have found that by doing 7c1, because it's the x is being raised to the power of 1. And then I'm going to be multiplying that by 2 to the power of 6, and then by ax to the power of 1. So I know that I can work that all out, and I need to get an answer at the end of 224x in order to find my missing value of a. So again, just working through with the calculator, if I multiply 7c1 by 2 to the power of 6, it equals 448. And I end up with 448ax on this side equals 224x. I can get rid of the x's. 448a equals 224, so a must be 224 over 448, which is a half. So I've got my value there. Let's just highlight the answers we've got here. We've got b equals 128, we've got a equals a half. So the examiner can see that we've worked those out. So we're just left with finding a value for c, which is the coefficient in front of the x squared. So again, all we need to do here now is just use the formula. The third term would be 7c2. It would be 2 to the power of 5. And it would be my ax, which we now know is a half x, because we've worked out the value of a, and that would be raised to the power of 2. So again, if I do the maths here, 7c2 times 2 to the power of 5, and then I'm going to divide that by 2 squared, 4, to get my answer therefore of 168x squared. So my value for c here is 168. And again, make sure you show the examiner you've read the question. He wants the values for a, b and c, not the values of the whole term. It just wants a, b and c. So again, that's quite straightforward, but you just need to look at it and think, what can I know, what do I know, and what order do I need to do this to make it simple? And in this case, it was easiest to start with b, then find a, and then find the value of c based on the value of a. Let's get a little bit more tricky then. This question's using some wording here. It says, find the term independent of x in the expansion of 2x plus 3 over x squared all to the power of 12. Now, independent of x means it's the term that doesn't have x in it. In other words, x is to the power of 0. But we've got x in both our values for a and b here, and we know that this is going to start off with 2x all raised to the power of 12, and that's definitely not independent of x. And each time we're going to be raising x to the power and then dividing by x to the power of something, because I've got x on the bottom. Now I could, if I had lots of time in the exam, expand the whole lot out and just find the term that's independent of x. But we want to be really smart here, and we want to be able to go straight there with a nice easy solution. So what I know here from my formula, again down here, is that my NCR, and here it's going to be 12CR, multiplied by 2x to the power of n minus r, that's 12 minus r, multiplied by 3 over x squared to the power of r, will give me a result where x disappears. In other words, x to the 12 minus r would have to equal x to the 2r, because I'm going to divide x to the 12 minus r by x to the 2r in my solution, and I'm hoping they disappear. And they'll disappear if 12 minus r equals 2r. If I rearrange that, 12 equals 3r. That means r must equal 4. Now, I can go straight there now because I know that my term is the term where r equals 4. So I can just plug that in now to the formula. 12c4, 2x to the power of 8 and 3 over x squared to the power of 4. And then if I multiply that out, I'm going to get 12c4, which is 495. 2 to the power of 8 is 256. And 3 to the power of 4 is 81. And of course the x's will disappear here because I'll have x to the power of 8 divided by x to the power of 8. So I'm just left with a term independent of x, and I get a nice big answer there of 10264320. That's not quite so easy, but this method that I just showed you here of working out algebraically to find your way to the exact term will save you a lot of time than having to work out every term or using trial and error to get to the answer. Of course you'll get there, but it'll just take you a long time. Last question then on this little bank of questions is another working backwards question, and this requires the knowledge of factorial notation that I showed you in an earlier video. So if you're not comfortable with manipulating with factorial notation, go back to that video and have a look and remind yourself before you try this question. But here we're asked to find the value of n. We don't know what this binomial has been raised to, but we know the coefficient of x squared is at 1125. So what we can do is write down what we know. We know that nc2 multiplied by 1 to the power of something, which disappears, and then by 5x all squared would give an answer of 1125 x squared, because we're told our coefficient is 1125. So if I do a bit of multiplying there, I can see that nc2 times 25 x squared equals 1125 x squared. So I can divide by 25x squared here just to find that nc2 is equal to 45. Now, if I go over to the other side here, now we know what nc2's got to equal. Let's write that down as we know it. That means n factorial over 2 factorial times n minus 2 factorial has to equal 45. Where did I get that from? Well, that's also down here on the formula sheet. NCR is n factorial over r factorial times n minus r factorial. Now, the trick that I showed you before is we can simplify that, because n factorial can be rewritten as n times n minus 1 times n minus 2 factorial, all over 2 factorial n minus 2 factorial equals 45. So I can cancel down the n minus 2, and I end up with, I can multiply by 2 to get 90 on the other side. I end up with n times n minus 1 equals 90. Multiply that out, n squared minus n, bring the 90 over, I end up with a quadratic. N squared minus n minus 90 equals 0. You could use the quadratic formula if you can't see it, but I can see that that is n minus 10 times n minus 9 equals 0. So n equals 10 or n plus 9 that should be, or negative 9. But my question says find n if n is greater than 0, so n must be equal to 10. And again, make sure you make that clear to the examiner so that they know you've read the question carefully. Don't just leave it as 10 or minus 9. So that's not easy, and it requires a little bit of thinking through and using skills that we learned earlier, but it's the kind of question you might well, especially in the higher level paper, get asked to answer. I hope you found that first set of questions useful. Practice, make up your own questions, use the questions in the book. And in the next video, I'll show you a further set of styles of questions that are a little bit different from the ones we've just done. But for now, thank you for watching. Don't forget to like this video, subscribe to my YouTube channel, IB Maths Intense. Tell your friends I'm here, of course, and drop me an email on ibmathsintense@gmail.com if you've got any questions, any requests, or if you spotted any mistakes in what I was just doing there. But for now, you take care and enjoy your maths.